Okay, this is lesson 4.3, which is called Proportional Relationships and Graphs. In the last lesson, in lesson 4.2, we learned what a proportional relationship is, right? A proportion is basically a statement that says two ratios are equivalent. We also learned that a proportional relationship is a relationship that has a constant rate of change. We learned how to find a constant rate of change from a table. We also learned about the equation that can represent a proportional relationship between x and y. So that equation was y equals kx. And the letter k is a new variable that stands for the constant of proportionality. That was all in lesson 4.2. Now, in lesson 4.3, what you'll see is you can find all of that information that we learned how to find in a table. You can find that in a graph as well, okay? And that's what lesson 4.3 is about. So let's start with some definitions, okay? A graph represents a proportional relationship if it is a straight line and it goes through the origin. So the origin is 0, 0 on a coordinate plane. Okay, so what does that actually mean? If we graph some points on a coordinate plane and we get a straight line that passes through 0, 0, then we have a proportional relationship. So how do we do that? All right, let's take a look about, and we'll read the situation and then we'll go through how to do it. First, it says the table shows the relationship between how much a cleaning company charges and how much time they work. Graph the information and then answer this question: is the relationship proportional? All right, so step number one, we're going to take a look at this table, right? We've got hours and cost. So if the cleaning company works for an hour cleaning your house, they will charge you $45. If it takes them 2 hours to clean your house, they will charge you $90. If it takes them 3 hours, they will charge you $135, and so on, okay? So the question is the relationship between the number of hours they work and the cost that they charge you, is that relationship proportional? That's the question. We can tell that from the table. We know how to tell that from the table. We would find each of the rates, right? We would do y divided by x, y divided by x, y divided by x, y divided by x. If we get the same number every single time, we know the relationship is proportional. But you can also tell it from a graph, okay? So first of all, let's figure out what is x and what is y. Remember, x is the independent variable. That is something that will happen on its own. Okay, if it's independent, it's going to happen no matter what. It's going to happen on its own. It doesn't depend on anything. Okay, between the time and the total cost, time is independent. So 1 hour, 2 hour, 3 hours, those time is going to happen no matter what. Okay, and so you have to work 1 hour before you get paid, right? So, or you have to work 1 hour before you can charge your customer the $45. So the time or the work for the 1 hour has to happen first. That's how you know which one is independent. The independent variable happens first, and the dependent variable won't happen unless the independent variable happens first. So the hour worked is our x variable, because that has to happen first. And once the work is done, then you can charge your customer. So the cost or the money is the y variable, okay? So let's also label our graph. We know that this is the x-axis and this is the y-axis, right? So down here, this is time. And if I look at the number of hours, I just need to go up to 8. So I'm going to put 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 hours right there. And on the y-axis, we have total money, okay? And it goes all the way to 360. So this is, I'm going to turn this sideways, and I'm going to write here, total money. Total cost, I guess. And it's in dollars. Okay. All right, I'll put it back straight. Now I'm going to label it, right? I'm going to label it. And what we get here is I have to go all the way up to 360. And I have, if this is 0, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. 360 divided by 9 is actually 40. So I'm going to go up by 40 each time. Okay. Or actually, maybe I should go up by 45. Okay, let's do that. Let's go 45, 90, and let's just use our, so we're allowed to use a calculator, right, in this module. So let's just do 45 plus 45 plus 45 plus, so that's 135 is next. 45, 180, 225, 270, 315, 360, and then 405. Okay, so hopefully you can see the way I labeled that. Notice I'm labeling the line, not the space. This line right here is $45. This line right here is $90, 135, 180, 225, 270, 315, and so on. And these lines down here, this line is 1 hour, 2 hours, 3 hours, and so on. So now it says write the data as ordered pairs. So X is 1, Y is 45. X is 1, Y is 45. Okay. X is 2, Y is 90. X is 3, Y is 135. X is 5, notice we skipped 4 there, we have to pay attention to that. Y is 225. X is 8, Y is 360. So we have written our data as ordered pairs, and now it says graph the ordered pairs. Okay, so when X is 1, Y is 45. When X is 2, Y is 90. When X is 3, Y is 135. When X is 5, I'm skipping the 4 here. When X is 5, Y is 225. And when X is 8, Y is 360. So 360 and 8. All right, okay. And now I'm going to get out a ruler. Here's a ruler. We have rulers in class if you need one. And I'm actually going to use a pencil for this. And I'm going to see if I graph, if I graph these together, okay. Do I get a straight line, and does it go through the origin? All right, yes, it does. So check it out. I graphed all the points from our table, and it goes through the origin. So the origin is right there, and the line goes through the origin 0, 0, and it is a straight line, okay? If you have that, remember, a graph represents a proportional relationship if it is a straight line and it goes through the origin. So, because this line, the graph is a straight line, right? The graph is a straight line, and it goes through the origin. So the relationship is proportional. Okay, so the answer to this is yes. Is the relationship proportional? Yes, it is. Okay, the next thing we're going to do, in the last lesson, we learned how to write an equation from the table. And we learned that the equation is y equals kx. And the letter K stood for the constant of proportionality, or the constant rate. If you have a proportional relationship, you will have a constant rate. And we can figure that out from our graph, okay? So now that we know it is proportional because it's a straight line and it goes through the origin, we can write the equation. So the y and the x are always changing, right? So when x is 1, y is 45. When x is 2, y is 90. When x is 3, y is 135. Okay, so the x and the y are always changing. So the equation that we're going to write is y equals k times x. And remember, the y and the x are always changing, but this k should be the same. So we should be able to write the equation for this exact, we should be able to write the equation for this exact graph and this exact table, right? By finding what is the value of k. So how do we do that? How do we write the equation for this graph, this table, the equation that goes with this data? Okay, how do we do that? To write an equation for the graph above, we're going to choose a point on the line. Okay, so I'm just going to choose this one right here. Okay, I'm going to choose this point right here. And that point is x is 3, y is 135. Okay, so I'm going to choose a point on the line. I'm going to choose x is 3, y is 135. Okay, that's step number 1 in writing an equation from a graph. Choose one point. This works if the graph is a proportional relationship. If it's not a proportional relationship, this won't work. So it has to be a straight line that goes through the origin. Then you can find the equation, okay? So I picked one point, 3, x is 3, y is 135. Then I'm going to find the constant of proportionality. Or the k value by putting y over x. So 130, so I'm going to put y over x, right? K equals y over x, which is 135 over 3. And now I'm going to get out my calculator, right? That's my dog. I'm going to get out my calculator and I'm going to do 135 divided by 3. And I get 45. So 45 is the constant of proportionality, or k, right? So the equation for this graph, okay, this graph right here in this table, this data is graphed on this graph. And the equation for this data is y equals 45x, right? So basically the equation we know is y equals kx. So we put, in place of k, we put this 45 because we figured out what k equals, because k equals y divided by x. So we pick one point and we take the y and divide it by the x and we get 45. And we know that it's going to be the same for every point because we know it's a proportional relationship. And we know that because it's a straight line. If we did it on the table, we could do y divided by x. 45 divided by 1 is going to be 45. 90 divided by 2 is going to be 45. 135 divided by 3 is 45. We already did that one on the calculator. 225 divided by 5 is 45. So every time we divide y divided by x, we are going to get 45. But once we graph it and we can see that it's a straight line going through the origin, then we know it's proportional and we only have to pick one dot. We only have to pick one point. We can pick any of them and we will get y divided by x equals 45. And then we can write our equation. Y equals 45x and put the 45 in place of the letter k. Okay? So that is how you figure out if a relationship is proportional from a graph. You basically take the data in the table, make ordered pairs, graph the ordered pairs, see if the graph is a straight line that goes through the origin. If it is, the answer is yes, you have a proportional relationship. And then to find the equation from the graph, you just take one of the points, divide the y divided by the x, 135 divided by 3, and whatever you get for your answer, that is your k value or your constant of proportionality. And then you can write your equation by putting that number in place of the x or in place of the k in the equation y equals kx. Okay?